All right, so let's talk about the review on area. Okay, you've got to know those formulas. So again, make sure that you've got those formulas nice and handy so that you can use them when you're studying. Okay, in the meantime, let's get going. A parallelogram with base 5, height 11. So first of all, we'll draw a quick picture. The base is 5 and the height, which would be that altitude, is 11. The formula is always what I write first, area base times height. So or I'm sorry, base times height, so 5 times 11 would be 55. Okay. Second guy, we've got a rhombus, and they gave me the two diagonals. So the two diagonals are, this whole thing is 8, and this whole thing is 12. I don't need to split it up because the formula for area of a rhombus is 1/2 diagonal 1 times diagonal 2, and I have both those things. So you can just go right to the formula. So I get 48. All right, an equilateral triangle with side lengths of 16. I would not use the area of a triangle formula with the 1/2 base times height. I would use the area of an equilateral triangle. And that is side squared root 3 over 4. So that would be 16 squared root 3 over 4. And let's see, that should be 64 root 3. Now, you can do it the long way, but I prefer this way. Okay. A square whose perimeter is 100. Okay, so if the perimeter is 100, I'm going to divide that by 4, right? And so that makes each side 25. And the area of a square is just one side squared, or in this case, 25 times 25, or 25 squared. And so we end up with 625. None of these had units, but if they did, we would have units squared. Okay. This one we want the area of the shaded region. So when you have a shaded region, the easiest thing to do is take the area of the large figure minus the area of what you don't want, right? So the big shape is a rectangle, and that particular rectangle, base times height, is a 9 by 13. So the big shape, the whole big figure is 117 square feet. But we're going to get rid of the part we don't want, which is the triangle. So we're going to do 1/2 base times height because it's not an equilateral. And so I have 1/2, the base in this guy was 8, the height was 4. So we have minus 16. So we end up with 101 square feet for that area. So again, if you have a shaded area, you can just do the big shape and then take away the part you don't want. All right, the following is an isosceles trapezoid. That means these two sides are the same, and that means you're going to drop both those altitudes on the ends. So I'm going to drop that guy and that guy. That means this triangle is the same as that. That means this is 16, which means that I have 4 left over, so each of these little parts are 2. And then this is a 30, 60, 90 triangle on each end. So this is the side across from 30, so that's the nice one. So I could double it to get this side. So this side would be times 2, 4. And then I take this side times root 3. Same thing, this one's 4, this one's, but we don't need all that. Now let's get the area. Formula for area is 1/2 base 1 plus base 2 times height. So my two bases are 16 and 20, and my height was 2 root 3. So then I've got 1/2 of 36 times 2 root 3. I could do 1/2 of 36, so I get 18 times 2 root 3, which is 36 root 3. And this is millimeters squared. So there's my area. Now the perimeter, I just need to add up all the sides. So 16, 20, 4, and 4. And so from my perimeter, I get 44. And perimeter is just length, so it would literally just be millimeters, not squared. So be careful on that. Okay, the following is a rhombus. We know the formula for a rhombus is 1/2 diagonal 1 times diagonal 2. So they told me the perimeter is 60. So I'm going to divide that by 4 and get that each side is 15. So that's the first thing that I'm going to mark. One diagonal is 10. So this one I will need to draw both, and I will need to bisect it. So if the whole diagonal is 10, each of those is 5. So to get the area, I'm going to have to solve for this little piece in that right triangle. Well, remember, when you have two sides, you can use Pythagorean theorem. Now, the hypotenuse is across from the right angle, so that's 15. So 5 and x are my legs, and 15 is my hypotenuse. So I've got x squared equals 200, square root. I can simplify this because this splits into 100 times 2, so this is 10 root 2. But careful, That's just this part of the diagonal. The whole diagonal would be 10 root 2 times 2. So the other diagonal is 20 root 2. So one of the first diagonal was 10, if you remember. This diagonal ended up being 2 of these, so 20 root 2. Then I can multiply half of 10, which is 5, times 20 root 2, which was 100 root 2. Remember, you're not taking half of both. This doesn't say 10 plus 20 root 2. You're only taking half of 10, and then you get 5. And then I did 5 times 20, so that was how I got the 100. And this one is in meters, and so it's square meters. Okay. In 8, we know the perimeter is 108. Find the dimensions and its area. So I got a lot to do here. All right, first of all, I know that the perimeter is 108, but in a rectangle, I would probably first label my other sides so that they match, because I don't want to just add these two. That wouldn't be the whole perimeter. So then I need to add these all up. Let's see, I got 1x plus 3 is 4, plus 1 more x is 5, 6, 7, 8. So I have 8 total x's. When I add those up, I've got a -1 and a -1, and then 2 positive 5, so that's 10 minus 2, so I get plus 8. I'm adding all of those together, and then that should be equal to my perimeter. So then I'm going to solve that. I get 100 divided by 8, which isn't terrible. It's 12.5. So now that's none of my answers yet. I want the dimensions of the rectangle. If I want the dimensions, I'm going to have to plug in x to both parts. So that's the first thing I'm going to do. I'm going to plug in x to that side, and I'm going to plug in x to this side. And I'm going to get the two dimensions. So the first dimension ends up being 36.5, this side, inches, by 12.5 plus 5 is 17.5 inches. So there's my second. So those are my two dimensions. And then they want the area. Okay, well, area is not bad. A rectangle's area formula, just base times height. So my base was 17.5, that dimension, and my height was 36.5. So I get 638.75. Again, I highly recommend squared, a calculator. Notice these ones are not squared because these are just lengths. This is squared because it's the actual area. All right, in number 9, I would pay attention to the fact that this was isosceles, and then I dropped the altitude. So what does it do? Splits the base. So these are each 10. So then we need x, and I can use my Pythagorean theorem because I know 2 of the sides. So I'm going to do the 2 legs are x and 10. The hypotenuse is 16. So I'm going to use that. So I get, let's see, 156 after I take away 100. I have to square root that. 156 is definitely divisible by 4. So this splits into 4 times 39. And then that would be 2 root 39. So the height is 2 root 39. Now we need to do the area of the triangle. Don't forget, it's 1/2 base times height, but be careful because your whole base is 20, not 10, right? So the base was 20, and the height that met it was this guy we found, 2 root 39. So then I end up with 20 root 39, because half of 20 is 10, times 2 is 20 root 39. And there were no units, so that's your final answer. Okay, oh, we're back to a rhombus. Perimeter is 20, divide this guy by 4, each side is 5. One of the diagonals is 6, so since I'm going to need the other one, I'm going to have to draw both and split this 6 into 3 and 3. So I can solve for this little piece, right? That's a triple, 3, 4, 5. So this little part is 4, but be careful. The whole other diagonal, AC, isn't just 4, it's 8. Okay, so now the formula is 1/2 diagonal 1 times diagonal 2. So my whole first diagonal was 6. My whole second diagonal was 4 plus 4, 8. So then I end up with 24. And this one, I didn't have units, so just 24. All right, in 11, it's a trapezoid. We want x in the area. Well, the first thing I would do, if it wasn't already done, is drop my altitude, but I already had that. Then I would transfer this little 6 over here, because it's a rectangle. And, ooh, I can solve this little right triangle because I have 2 sides. I could set up Pythagorean theorem, or that is a triple. It's a 6, 8, 10. And if this is 8, and that whole thing's 28, that makes this 20, which means x is 20. So there I found x. And then remember, the area is 1/2 base 1 plus base 2 times height for a trapezoid. So we've got our 2 bases, 20, and the whole thing, 28. So 20 plus 28 times the height was 6. So I did do a little work there, but it wasn't terrible. All right, so then we end up with 144 for our area. Just make sure you're dropping those altitudes and you're keeping that rectangle. You're using that rectangle's information. It's always a rectangle. Every once in a while it ends up being more so a square, but it's definitely always a rectangle. All right, find the area of a trapezoid with parallel sides measuring 5 and 10 and a height. Oh, this isn't bad. The parallel sides are the bases, guys, and they literally tell you that the height is 3. You have everything you need, but you needed a drawing and probably the formula so that you knew you had everything you needed. So I have both bases, 5 and 10, and I have the height. So then I have 15 times 3, and then take half of that. So I've got 22.5, and this is feet, so feet squared. 13, find the area of the rhombus. Formula for rhombus's area is 1/2 d1 times d2. Good news, they gave you diagonal 1 and 2. You don't even have to do more work than that. Boom, half of 20 is 10, and this is meters squared. See what I mean by knowing those formulas? It really makes it easier. All right, 14, this time they gave me the area, and it's a trapezoid. So the first thing I would do is write the formula, and then look at what I have and what I need. So it looks like I have the area, so that part is 90. So 90 equals what I get. 1/2, I have base 1, 2x plus 2, plus base 2, 8x plus 6. So that's a little weird because they're expressions, but it's still the base. And then times the height of 5. All right, let's simplify this business. I've got 2x and 8x, so 10x, and I've got 2 and 6, so 8. For me, I would like to get rid of the fraction next, so I'm going to multiply both sides by 2. So I get 180. And then I can distribute the 5 now, or I can just divide both sides by the 5. And I like to do that because then I don't have to worry about distributing. So then I get 36 equals 10x plus 8. I subtract 8 on both sides, and I get 28 equals 10x, and then I divide by 10, and I get x equals 2.8. And this was meters squared, so this length would be meters. All right. The area of a rectangle is 50 and the height is 4. Again, if they give you the area, I always start with the formula, base times height. And then I fill in what I know. The area is 50, the height is 4. They want the perimeter of the rectangle. Okay. Well, let's see. We already know the height's 4, so we could write that down. But we got to find the base, so I'd have to divide by 4. So I have 50 divided by 4. I get 12.5 from my base. But remember, you got 2 of them. Then you can add this up to get your rectangle. So I end up with 33. And this is centimeters, because remember, it's perimeter, which is a length. So this is where the drawing really helped, because then I could see, oh yeah, I need 2 of these 4s. I need 2 of these bases I found, and then that way I don't make a mistake. All right, 16, these are our last two. An isosceles trapezoid. Okay, so we know it's isosceles. These two guys are the same. The bases are 15 and 27, and the legs are 10. Find the area. Okay, isosceles trapezoid, drop both altitudes, bam, bam, on the edges. This side immediately brings that 15 down. And so 27 minus 15 gives me 12, so that makes each of these 6. And then I can do my Pythagorean theorem to get this missing leg. Remember, 10 should be the biggest, so that should go where the hypotenuse is. So I can do my Pythagorean theorem, or that is a triple. Once again, that is 8. And now I have everything. Area equals 1/2 base 1 plus base 2 times height. So my two bases were 15 and 27, and my height was 8. So I ended up with 168. And this is area, so inches squared. Last one. This is a composite figure. So the first thing I would do is make it into 2 manageable shapes. So I'm going to use that rectangle, which is a 6 by 12. So that part's 72. And then this guy, I know these sides are both 5, but this is the side I need. And it's not 12 because the whole thing's 12. If this is 4, then you can do 12 minus 4. That would make that part 8. Okay, now what do? This is an isosceles triangle. So we need to drop an altitude, which splits the base into 4 and 4. And this is a special triangle. This is a 3, 4, 5. So this is 3. So then just this triangle is 1/2 base times height. The base, the whole base, careful, is 8. The height is 3. So I get 12. So that part's 12. This part's 72. So your final answer is 84 square centimeters, because they did say here everything was centimeters. Okay. The only thing that wasn't in here was trig, and I would be, expect to maybe see some trig tomorrow. So if I gave you a rectangle and I told you this little angle was 58 and this side was 7, you could solve for those two sides so that you could solve for the area of the whole rectangle, right? You'd have to use trig to do that. So that's the only other thing. All right, I would review these. I would make sure you know your formulas because you won't be given them tomorrow. And good luck.